So in today's video we will continue the remaining topics of database management system. So here first we will discuss about the data abstraction. So what is data abstraction? Data abstraction refers to the process of hiding the complexity of how a data is stored and maintained, like presenting user with the simplified instances. It ensures that user interact only with the database without needing to understand the inner manipulations that we are working on. Data abstraction is divided basically, there are three levels of data abstraction. First is physical level. In what is physical level? It describes how a data is physically stored in the database, including details about storage structure, indexes and access methods. For example, if we consider data stored on hard drives or SSD using specific file format. Second is logical level. It mainly focuses on what data is stored and the relationship between data entities are. It defines the data structure of the data as seen by the database administrator and developers. And third is view level. It basically represents the user interaction with the database, providing multiple views tailored to specific user need. For example, if we consider any banking system may show a case account balance to customer but provide detailed transaction reports to managers. And so it is all about data abstraction and the three levels of data abstraction. The next is database management system. We will discuss some of the database management terminology that we will look into. First is data independence. It actually refers to the ability to change the schema at one level of abstraction without affecting the schema at another level. And types, there are two types. First is logical data independence, ability to modify the logical schema without altering the application. And second is physical data independence, like the ability to modify the physical storage of data without affecting the local schema. So these are the two subcategories of logical of data independence, that is logical data independence and physical data independence. Second is instances, or you can say a database state, snapshot, etc. It actually refers to the actual data stored in the database at a specific point in a time. For example, a database containing customer details and their transaction at 10 a.m. on a particular day. So that is one particular example that we consider under this title. SEMA. What is SEMA? The structure that defines the organization of data in a database. Like basically there are again three types of SEMA. First is physical SEMA, details the storage of data. Second is logical SEMA, outlines the logical structure of the data. And third is view SEMA, describe the user view. So next we will talk about the DBMS architecture. So what are the database management system architecture? So there are three architectures basically. If we consider first tier, two tier and three tier architecture level. So talking about the first tier architecture, in that architecture the database and application are basically on the system only, on the same system, and the suitable for standalone application like personal databases, for example MS Access we consider. Two-tier architecture is like the client send request to the server which processes the data and returns the result accordingly. For example, application with front end like graphical user interface interacting with the backend database, if we consider it. And next is like three-tier architecture. In that involves the three-layer presentation, that is user interface, application, that is business logic, and database, that is data storage. For example, web-based application where the browser, server and the databases are distinct entities. So basically these are the architecture of the database management system. Now we will look at the server system architecture. In that server system architecture we will first look at the centralized system where all database functions are handled on a single central server suitable for small scale applications. And second is client server system where the client handles the user interface while the server manages data storage and processing. Example, if we consider banking system. Third is parallel system Multiple processors work together to process queries simultaneously and thereby improving the performance. Fourth is distributed system. Data is stored across the multiple locations and queries are processed across the distributed servers. For example, if we consider global e-commerce platform, that specifically comes under the section of distributed systems. The next is classification of DBMS. So the first is on basis of data model. So on the basis of data model, there are two basically classification: relational data model and object oriented data model. In a relational data model, we generally use tables to represent data and relationships. For example, MySQL is one example that we could consider under this relational data model. And object oriented data model combines the data and methods in object. For example, object database, object DB. Second is on user number. In that user number is further bifurcated into single user system and multi-user system. In single user system, what happens? One user accesses the databases at a time. A personal finance management software could be considered under this example basically. And multi-user system supports multiple user accessing the database concurrently. For example, ERP system. Second, the importance of database design. It is very important because databases design are the one which plays a major role here. First is ensure data consistency and accuracy. Second, optimize query performance. Third, facilitate easy data retrieval and reporting. Fourth, reduces redundancy and ensures efficient storage. Fifth, enhances scalability to accommodate growing data needs. Sixth, simplifies database maintenance and updates. Seventh, enables better enforcement of data security. Eighth, improve decision making with well organized data. Ninth, prevent data anomalies during updates, deletion and insertion. 10, aligns database structure with organization goals. So these are some of the importance of database design that we should consider while making it. Next is strategies for SEMA design. So there are basically two strategies: inside outside strategy and mixed strategy. In inside outside strategy, it basically focuses on core business entities and their attributes first. Example, starting with table for customer before expanding to order and products. Second is mixed strategy, which basically combines top down and inside out approach. For example, designing the database by identifying a high level processes and core entities simultaneously. Next, we will look at some phases of database design. Requirement analysis. First is requirement analysis. Gather user requirements and identify data needs accordingly. Second is conceptual design, which generally create an entity relationships model to represent entity attributes, relationships and other such factors that we could consider. Third phase is logical design. What we consider under the logical design: translate the ER model into relational SEMA, normalize the SEMA, and second, we normalize the SEMA to eliminate the redundancy. In fourth phase, we generally consider physical design. What is physical design? It defines how a data will be stored on the disk, including indexes, file organization and other such storage factor that we consider generally. And fifth is implementation. In implementation, we use a DBMS to create a database structure and populate it with the data. And sixth is testing refinement, where we test the database with a real world scenario and optimize for performance and accuracy accordingly. So finally, we will discuss the conclusion here at the end. First, that is like a well structured and efficiently designed database is the backbone of modern information system, which is likely to be an important factor here. Data abstraction ensures a clear separation between how a data is stored and how it is used, simplifying the user interaction. Similarly, the terminology and architecture of DBMS provide flexibility and scalability accordingly, accommodating diverse organizational needs. By classifying DBMS based on data models and user number, organization can select system tailored to their requirements. Server architecture, basically ranging from centralized to distributed, offers options for performance optimization and fault tolerance. Database design importance lies in its ability to ensure consistency, efficiency, security, while SEMA design strategy and phases ensure some methodological approach to build robust database. By mastering this concept, the professionals could create some systems that are not only functional but also scalable, reliable, aligned with business goals. So the ever evolving role of DBMS in real life application as such as banking, healthcare, e-commerce, logistics underscore its relevance in driving innovation and efficiently in today's data driven world. So basically these all things are all about DBMS. So thank you.